So hopefully this looks familiar by now, right? You might need a less light above. If you can get like half or something like that.
Put a light switch? Outside, why not behind the door?
It was unavailable.
You take note of this.
Yeah. Ooh. All right.
These are the fans. Are the fans good? Yeah.
So, hopefully this looks vaguely familiar. This is just a representation of kind of where we left off last time. Again, if anybody has any questions, just yell them out. I'd be happy to explain anything if I go too fast or you want me to do something over again. I did a kind of informal survey with my group and asked if they had everything in Rhino. And I think most people do. Would you guys agree with that in terms of this project you just did? You've got pretty much everything represented. Maybe you didn't do like solid wood and you didn't make little pieces of yarn or something. But geometrically, this is kind of what you want to have. You want to have at least one kind of projection, that you use. This model right now is at the 20 by 20 size that you just did by 20. And this is just a representation of one of those three planes. If you don't have that, I'll kind of backtrack a second. One kind of recommendation that I would have in order to do that, let me turn off these surfaces for a second, is to just draw those curves in Rhino kind of quickly. You can just go to your physical model and measure the distance. For instance, if I didn't have this kind of extrusion line in the top there, I could just go and do a measurement maybe off of that point as to where mine was. Let's say maybe I've got one here and I've got one there, and I can just kind of use that. If I've measured off of this corner here in real life, I can then just draw a line from that corner in the correct direction. So I would just use the line command to do that. Start a line is just going to be on that corner that I measured off of in my model, and then I'll just type in whatever my measurement was. Let's say it's 4. Oops, already set my direction, so let me backtrack a little bit. That's going to set a distance constraint of 4. And then I would just go over to the correct, I can use the smart track down here on the very bottom to go 4 in the correct direction. Now I've got a curve, so ignore that one I did because I just drew it out of nowhere. This is my curve that I've got there. And if I did something on the other side, maybe I'd measure something and it's 7 off of that intersection there. And now I can just connect the 2 points with a line using the end snap. So I've got a new endpoint and a new endpoint. And sometimes smart track can be really annoying, so I turn it off. Okay, so I know that, in my model, it's crossing through at that point. I can just extend this curve outwards to kind of cover up. So I would just use the extend command. Extend curve. It's asking for a boundary object, so I'm just gonna, you guys are familiar with the old extend by now. I could just kind of pick it. This might not work, we'll see. Give it a shot. That's not a boundary object. It worked. All right, so that's my new curve. That makes sense? I mean, it's pretty simple, but it's kind of a quick translation from the physical to it. So just because you have a model to get in Rhino, it's really kind of easy. So let's say you've done that, and you've got your curves here. If you don't have the surfaces, you can kind of, sorry, a lot of extra junk on there. Extrude this curve to make new surfaces. So I'll just use the surface ExtrudeCrv straight command. And I'm just going to extrude it straight down to the end of my box. So I'm just using the end snap there to extrude a new surface. And I'm going to do it with my other curve as well in the other direction. If it wants to go straight down, that's because you drew that curve in that C-plane, and by default it wants to just go in that direction. There's a little option in the beginning, the clickable option, that tells you to change the direction if it's not doing what you like. And then you can just use 2 points to draw the right direction. So I'm just going to go from here to there, and it's going to fix the direction for me. All right, so I'll go create that one, and then I'll create the final third one. Again, doesn't care what direction I want, so I'm going to tell it to go across it instead, and I can just snap to that. Okay. And should have something looking like that. So I've got my my planes cutting through. The next thing that I want to do, I'm going to turn those off for a second so we can get into the next step here. What we want to do at this point is kind of create a base solid. This is something that's going to be a jumping off point in terms of the massing. It's what we're going to be dealing with in the workshop on Wednesday when it comes to what are we actually making with this wire and solder and all that good stuff. It's going to be a wire frame of a base model volume, and this is going to be the jumping off point for the actual final design. We're going to do it by intersecting the model extrusions that you've already done. So my first step is to create the extrusions that we need to do it. So I'm going to take these, one of them, I only need one, and I'm going to extrude it. I'm going to go to Surface ExtrudeCrv, straight. I'm going to have the solid option on to say yes, because I want a solid to come out of it. And I'm going to make one solid there. I'm going to repeat it for my curves. If I have multiple curves, I'm just going to select whatever ones I have. So in instance, this is 2 closed curves, so I'm going to hold down Shift and select both of them. I'm going to extrude that again. You want to keep making sure that your solid option equals yes, because it'll turn off when you run it again. Now I'm going to do a third. This is my last one, and I'm going to repeat the command. Solid equals yes. I've got my 3 extras. So far, so good. They're kind of, I mean, it's basically very similar to that model that you constructed. It's just a kind of filling in of those projected curves that you've done. So we made sure when we ran that command, it said solid equals yes up there. Hopefully I remembered that. Let's see. Yeah, it looks like it. These are extrusion objects. They're simple objects, but they're the same as equaling a solid. And the next thing I want to do is actually intersect them. I want to use the Boolean Intersection command to do that. Because I can only use the Boolean intersection for 2 objects at a time, I just have to do 2 first and then intersect that result with whatever's left over. The order that you do it doesn't matter. There's only one possible result of those 3 extrusions. So I'm just going to do a solid Boolean intersection. Pick. But I will point out that it's asking for sets. So in this case, because I extruded 2 separate curves, I've actually got 2 separate solids there. I've got this little triangular one here, and I've got a larger one. You want to treat that as one object, so when it's asking for a first set, make sure you include both of them. Pick them both and accept that as your first set. And then for your second set, so just leave that as entire set. Don't try to do them all at one time and like pick some other ones and include them in your set because it won't register correctly. I'll pick this as my second set. When I did it, I had to delete. It magically disappeared because I had to delete input equals no. If you don't want to do that and you want to keep these around, you just run that command. So I'll pick that again. Of course, I have to remind myself to actually do what I said I'd do and not skip it. Actually, Boolean intersection might not allow you to keep the input because it's not giving me that option. So if that's the case, you can always just give yourself an extra copy. You know, I've got my originals here on this copy. I'll just make a copy of these objects. I'll right-click that layer and say copy objects to layer, and I'll do my new stuff on the result layer, and I'll turn that original layers off, actually. That was already on there, so let me give myself another one. All right, so got one on the result layer. Turn the originals off, that's my backup copy. Run the Boolean intersection. Clear the first set, second set. So that's my result from the first one. And I'm just going to run that again, and this time you use the one that's left over. So, yeah, again, the one set is going to be, what was the question? I can't do them all? No, I can't do them all at the same time. Yeah, it's just the way that this command thinks. First set, enter, second set, so that's okay. And my second set is going to be the one I just did. I could do this in reverse. So I'm left with a polysurface. If I look with the with this command here, this is kind of what I'm left with. I'm left with a polysurface. This one to open probably has a small gap somewhere in here or something like that. For all intents and purposes, this is my massing for the volume that's going to actually come out of this. So, congratulations, you've got something to work with now. I didn't plan this one in terms of how it looks or anything like that. This is just a kind of result of my extrusions. In terms of the process and for the model building, I want to get this thing out and flat so I can build a wireframe. It'd be kind of tedious to try and build it the way it is now. It's got a bunch of different facets to it and things like that. So I'm going to unroll this surface and then I'm going to use the outline as a pattern to kind of lay my wire pieces out. So I'm going to go into my layers. I'm just going to give myself a new layer for my stuff here. Pattern, flat surfaces, I'm going to call it. So the unroll command works for single surfaces. It also works for double surfaces as well. Poly surfaces. I'm going to go to surface and I'm going to unroll. It's called Unroll Developable Surf, or you could just type in UnrollSrf. It's got some options. I want to say explode yes, because with a complex kind of shape like this, if I try to keep them all attached and just flatten them out like a cardboard box, you kind of know what's going to happen, right? They're going to like overlap each other, and then it's just going to flatten out that way, and you won't need to separate. So it does give us, it'll spread out a bunch of little parts, but don't be too intimidated by that. A lot of these are kind of small. And not too much work, and they're all flat-faced surfaces as well, and they'll be numbered so you'll know where things go. So option is explode yes and labels equals yes. The labels are going to give us a label for the edge itself. There'll be matching numbers and also on the original, so I can look at the original and refer back to it. Keep properties isn't going to bother us right now because it's something that has to do with surface topology, and we've got flat surfaces. It's not a problem for us. Relative tolerance is just something that talks about if this wasn't a flat surface, how much it would change to unroll the surface and what kind of threshold is set. So this is my poly surface to unroll. I don't have any curves to unroll on that poly surface, like if I had an additional information. So I'm going to hit enter. gave me like a little laundry list of parts. It kind of is a little generous in the way it spreads it out, but you can kind of see how it's thinking. It's going to randomly kind of lay these out for us, but the numbers are corresponding. So if I look at edge number 1 and edge number 0 up here, this looks like it starts at the bottom of my model. So this is actually talking about that surface of my model. The sides of it are 10, 0, and 1, and that one is right there, 10, 0, and 1. So it's kind of a kit of parts at that point. So from here, it's going to be a method of whatever kind of works for you in terms of putting it back together. You've got the component parts. A recommendation for me would be, point out one thing that's good. By default, this command will just group the object in its little tags. These are called annotation dots, and you can see how they don't scale. They're always the same size. That works well in Rhino, not so great if you actually want to print it out, because they don't print out. They're just kind of graphic notations. So let's say that I did want to like lay these out and print them out as a template or something like that. Kind of just to go back a second, what are we actually looking at here? Are the surfaces important part or the edges the important part? Right. So depending on what you want to do and how you think about things, you could definitely leave them as they are and print them. You know, they're just going to give you the edge of the surface. If you needed to get rid of the surfaces for some reason, you just wanted to see edges, or you want to color code anything, it doesn't matter. I'll just show you one possible way to do it. If you want to create edges around it, and I'll just make a new layer for it, you could just do like borders for it. If you did want to do like some kind of color code or kind of fill or something like that, or like a numbering system. So I would just say curve from objects, duplicate border, which is going to look at any surface and draw a border around it. Select surfaces. I'm just going to pick my surfaces there. Okay, and now I've got the kind of borders of it. And you can see there's actually not that many parts. It's not quite as intimidating without those numbers kind of hiding around it. So those are there. I'll put that on a layer, and I'll turn that off for a second. With these annotation dots, if you actually wanted to print these out, you can do that. You want to turn them into text first. So the command for that is, and I'm not sure where it is in the menu, but it's convert dot. I'll see where it is on the menu for you. It's not on there, and that's why I don't know it. Okay, so convert dot, convert dots, text dots to convert. I can just pick these here, and I can tell it whatever text height I want, and my model is in inches right now. Delete input, I'll say no, I want to keep it because I want to keep my text dots. My output can be text. It can also be just points, but texts are good, and I can tell it the orientation, the alignment, all that good stuff. But then I can hit enter. 98 text added. So basically, what it's done now is kind of given me those numbers as well. They kind of do whatever is going to help me out. I did something inside of a group, so it's going to come along with it. If I ever needed to move things around, I would just ungroup that particular group and right. But since we're not actually taking these things and physically building them, like surfaces, and we're using this as a template for wire, right? Kind of just leave them where they are. They're not really getting in the way. I would say just maybe plot out a sheet and move these around to whatever kind of compression you want to do. Something like that, kind of build them all together. Any questions so far?
affected if you ran your Boolean operation in a different order?
No.
Do the same
Yeah,
thing?
there's only, for those, any 3 volumes like that, there's only one thing that has all 3 intersecting. It just doesn't want to think that way. Once 2 at a time. So we just do it that way. Anybody else?
I got a question. So you're just matching the size by numbers, right?
Yeah.
Okay, it's not the points.
Say it again? No, the points are just the points. They're going to be whatever the results are of the edges that are together. So every edge is numbered, and there's going to be 2 tags for every edge. So it's kind of just finding the corresponding number somewhere else. The corners are not numbered. Yeah. You might have to do a little bit of cleanup. I didn't plan this in terms of making it the simplest or most complicated. It was where we were left off. You might have little tiny facets or something like that, like really tiny surfaces as a result. That's kind of within your realm to maybe just simplify it, build it into another surface, or kind of do it, but don't try to kill yourself building a 2 millimeter triangle, right? Use a little bit of intuition on that. We're not looking for. The thing about this is if you come out with this thing, you know, and look at it in the context of that model you just made, it should make sense. It's kind of intuitive. Just because you haven't physically constructed it yet, you could technically pull this off if you really got crazy with the yarn, but fortunately we're not making you do that manually that way. Any other questions about this part? There's another part to it as well, and that is the generation of the landscape in terms of a horizon, which is going to be another new component. But I can move on to that if you're okay with this. Or,
yeah. Like if I may make another note about the unfold or the unroll, what's going to end up happening with this is that you're going to need to rely on the digital model to kind of complete it, because the unfold doesn't tell you if it's a convex or concave, right? So once we get moved towards the wireframe or doing the wireframe on this model, you're gonna have to rely on the digital model. So I would encourage that you find a way of assembling these shapes in a kind of unfold way that makes sense when you look at the digital model. So it might sound like, well, what are you talking about? What you'll see is that even though there's a few shapes, yes, it doesn't look like it's too complex, but there's a few real critical decisions to be made. Otherwise, the thing won't go together. But you'll see what I'm talking about. So one is have a system with the digital. We're also learning how to get it out of the machine to know how to actually put it together.
Can you color code the mass like individual sides, or does it, when you cut it, does it do all sides?
Oh, just in terms of like using that as another way to match them up. Yeah, you could do that. You would just have them. You'd have to put this on separate layers, right? Like if you had. Yeah, you would just take it. This is one object, right? It's a polysurface, so you'd have to explode it into 25 surfaces in this case. I'm going to select my dots for a second just to get them out of the way and hide them for a second, and kind of color code it that way, right? I mean, there's a couple things. You know, that's a great point. I'm trying to think of the. Another way to do it would be to kind of give yourself an order of operation. Like when I look at this, I think I would probably start from the ground up and kind of start doing it that way. And that's another thing that you could definitely do, is just give yourself an order of it, right? So let's see, what would be one way to do it? You could just use this. You're going to have this thing here. You can just run so let me do a kind of example. Like if I said I want to do this surface first, right? do dimension, annotation dot, and just say whatever you want to call it, step 1, and put it on that surface there. And sometimes it's a little tougher. You can see sometimes there is a center snap on a surface, sometimes there isn't. It's a little tricky. But just come up with a kind of consistent method. Let me take off my, I'm not actually sure what it's projecting to right now. I'll do like a near on the surface edge there. And it would just be, my step 1 is to connect those 2 edges, right? And I know those numbers. That would be a kind of a way to do it. And you could just right click it and change it to step 2. And just kind of build it that way. I think that would be a kind of literally take you only a couple minutes, but it'll kind of keep you tracking on it the other kind of way. That's the little things that I've learned along the way when I'm building models like this. It's whatever kind of system worksheet, but that extra work will kind of make it worth your while. You know what I mean? You always want to. It's gonna lay things out, but you always want to make sure if things get a little complicated that you're using the right side. You don't have things backwards. One kind of way to do that is if you go into, it should be available in your display, color back faces for objects. So if I just pick everything right now that's going on my model and I say, I can have a specific back color for the model. And that's a way to just make sure that you shouldn't be seeing any kind of back faces or anything like that, but it's a good way to just make sure, you know, because if I looked at this guy, I can make sure that he doesn't, I'm not looking at the back of it, I'm looking at the front of it. And it should have done it for this one. I'm not exactly sure why it didn't, so let me take a look at it.
When I start indicating what you represent as the top or the bottom, right or left, or front or back.
Yeah, like whatever kind of lingo is gonna kind of get you oriented. It's a kind of self-orientation of. It's more really of like understanding kind of spatially how a model goes together. Like those are my back face colors. I don't know why I didn't pick it the first time, but like that's a ghosted mode. But if I looked at it, it would kind of just make sure. Like if I flip the directions, that I shouldn't be seeing those out there. But every once in a while, you'll get thrown a little loophole or something like that, and it'll kind of make it all sense for you. There's also ways that like you could do it in terms of like simplifying it for you. If I have something like this and there's a couple parts to it, I could just isolate those parts and unfold them simpler, right? So if I took like a little part of it like this, right, and I did a solid and I said, well, I can just do a join, actually make it even easier, just do a join. It's a joined, and then I can just unroll that particular surface and see if it would unroll without exploding and keeping it together. Let's see. Still self-colliding a little bit on. Oh no, this is a smaller one down here. Still a couple self-collisions. And I think it's because of the little shape that happens in the back there. But something that is simple, it might be a little bit better with something like that. Any other kind of questions on that stuff at all? Or any commands that need to be seen?
Yeah, the obvious things are like the quality of the edge you're cutting, the accuracy, the cleanness of the surface. Once again, you know, what appears to you to be top or bottom. Remember, this is related to the topics to begin to do this. So there's going to be a sense of light and brightness.
Well, one thing to point out also is there's no top and bottom yet. And it's kind of just in this field, right? We haven't established that. And if there's no more questions, that I'll use that as a stepping stone to get into the next part of it. So let me just undo when I did the explode.
I want to make sure that what you say is understood. Don't always get what it represents versus how still floating in space.
All right, so I've got this stuff. This is just like unrolling stuff. I'm going to put that unrolled information on my unrolled layer here. So I'll do select surf. That's only going to pick the single surfaces, and I'll put that on that layer there. Okay. And annotation dots. So let's get back to what we've got here and go back to my surfaces for the slices that I did. Those are just back faces showing up there. If I look at their properties. Take that off for a second. So as a jumping off point, the next thing I want to do is I want to find the intersections for my object in terms of these three intersections. What we need to do now is establish like a new horizon, and this is the purpose of doing those three planes, is to kind of take those in space. Some of it's going to come from the actual automatic intersections that you've already seen in your model, and the other parts are going to be how you connect it and extend it outwards. So that you're going to have like some basic kind of guts to it, for lack of a better word. So I'm going to just take my my intersections here. I'm gonna just make a new layer for intersecting curves. I'm gonna run the intersect command. So that's under curve, curve from objects, intersect. I'm gonna pick my three surfaces. Okay, so that gave me these three curves, and obviously yours are gonna be different than this. It might come to a point, I noticed when I was doing a couple tests, that they might actually intersect, because however you did your projected planes, something like that would create like a pinch, and they all kind of run through that. I would say in that case, it would be just as simply moving one in a planar fashion. And I'm perfectly fine with that. So what I mean by is, like, if these were running into each other, mine aren't, mine are fine, but it could have very well been that they did do that and they were just kind of crisscrossing each other in 3D, that you move it planar and kind of give yourself a bit of breathing room in terms of the next step. Because what we're going to try and do is make a continuous surface through those three curves at first, right? So let me turn off my surfaces for a second, and I'll turn off the solid and kind of concentrate on this part, boundary. Okay, so I want to start by just making a surface from these three curves. I'm going to do that by just doing the loft command. I'm going to pick my surfaces. You just want to grab them all at one time. If you grab them out of order, that's bad because it'll hop and skip orders. You just want to do it in a natural progression. Hit enter. And I want to use the option straight sections. That's just going to give me flat surface sections, okay? Don't change any of these other options, and I hit OK. So that gives me this surface, and in this surface, I also need to take a look again at my context, what's going on in here, and what's also going on, more importantly, with my slices that are going on here. So that's my new surface, right? hanging out. Won't let me grab it. There it is. That's a polysurface. We need to get this guy to the ends of the surface as well. So in this case, I want to extend it and cover up the box. You might still have a curve. It all depends on what's still in your Rhino, right? But let's say I don't. I can use the dupe edge to make a curve. So I'm going to go to curve, duplicate edge. I'm going to duplicate that edge. With the intent of running it out to that way. What else is happening? Over here, I've got a kind of triangular that's cutting me off from going over to the edge there. And I've also got a triangle that's cutting me over to the edge there. But I basically just want to take that plane and extend it outwards. This is me choosing this, right, in terms of where I could go. I could have, instead of going off to the left there, I could have gone vertically up in this direction and taken it up that way, and then with my other surface gone in some other direction, maybe in this case off to the left or something like that, right? The important thing is that whatever I do contains this poly surface that I created in here, right? This is kind of the inclusive part. From here, I take it in what direction I want to go. So I could go downwards, I can go over. So let's say on this one, I give it another fold and I go downwards. I'm going to just draw, I'm going to give myself, I don't want to dupe this whole edge here, so I can just draw a triangle with the polygon command with the points that are on the ends there. So make sure I'm using endpoints. I'm just going to draw this curve here, right? I'm going to use the planar surface command, surface. I've already got the curve picked, so I can just say planar curves. And it's going to make a surface for me. So that's my new surface. And let's say on this one, I want to go laterally over to the left. I'm going to just draw another polygon with the polyline command and go pick those 4 corners. And use the planar surface again. All right. So let me get rid of my other surfaces, take a look at what we've got. Looks like I need one more over to the side here. Surfaces. So now I've got the resulting surface here that goes across the top of my box that I've got going on there. This could, in top view, should always be a square, and now I can kind of cover the ground of my whole top surface there. So at this point I would want to join these together. To a single poly surface. And I want to make it a solid now. The kind of end result of this is going to be a solid, and this is the top of what I have. It's going to be based on that box that I've got. So if I look back at my, my bounding box that I've got, this box here, I broke mine up to play around with it, but it should just be a solid kind of box here, right? I'll do an edit, join. I'm going to make a copy of that to my layer here that I've got. Copy objects to layer, turn the boundary off. At this point, I can split this up. I can probably do it right with a Boolean split. I'll give it a shot. Maybe it will work. Splitting it with this polysurface. Yeah, should work. Hide that for a second. That's leaving me with this polysurface. It's kind of hanging out. I've got a copy of it hanging out right there because that was the input. So it kind of kept that, but you can see that this is a closed polysurface right up there. That's good. I want that because from there I can actually now account for what? The massing that I've got. This massing is just kind of hanging out there that I created. This object here, right? I need to kind of house this in here and support it at this point. Right now they're just kind of existing together. So I'm going to do a difference. I'm going to do a solid Boolean difference. I always subtract the B from A, so I always pick the thing that I'm subtracting from first. It's this object, and hit enter, and then the thing I'm subtracting with, I'll say delete input equals no, because I still want to keep that object. That's my subtraction object. And now I've got a base here. I'll make a copy of it so you can actually see it a little bit better. And I've got an object here. That would socket into that base. And that's going to be the basis for my final model, as how I'm going to sit it on there. Right? Does that make sense?
So that's all we need wireframe.
We're going to talk about the construction of this on Wednesday, because I don't want to do an overload. But we're going to take this solid and we're going to deconstruct this solid and build it as a singular base, kind of similar to your very first model with the horizons when you guys had a base like that. It's going to be similar to that, so it's something that is somewhat hollow and that we can sit it on, right? And so you're going to have this base that's suspending the wire model, and that's going to be the jumping off point for constructing the final model. So I would say the end products that you want to have coming out, kind of moving forward, is, you know, the setup for your wire model. So the kind of unrolled boundaries for all the single surfaces that you can attach it back together, and this solid. This is stuff that can be totally done in Rhino, and we're going to cover how to get this into something we can build in the next step on Wednesday. Yeah.
So you basically chose to keep the top as your top, but what would we do, like, say right before that step, if we chose that we actually wanted to flip our mass and use the bottom as the top, or whatever?
So
We just spin the entire thing.
yeah, exactly. So, you know, the mass is always, the object's where it's at, and it's the manipulation of it. So yeah, that's totally we can do, and we can do that. It's real quick. I'll kind of backtrack until I've got.
And I think
This guy.
That's a key point right here.
Yeah.
And we talked about this too, as a faculty, like, this is what we would encourage you to do with the three surface right here, like the three surfaces. Very easily you could pull out about 5 different combinations of how to do that, right?
Yeah.
And I would actually really encourage you to take that on and say, okay, can I do it one way? Can I do it another way? And see how it intersects your actual volume.
Mm-hmm.
And based on that, I think you could settle on one or the other, right? To say, like, it's actually producing some good intersections. Yes, what is good? Like, one is like one I think you're making sort of design decisions that are either intriguing to you or say they're about splitting the volume into 2 equal halves, or you really like the way it nests in the valley, or it's below, or flipping it, right? But allow yourself to see it at least in 5 different ways, right?
There's plenty of options.
The combinations of the surfaces is, yes, there's easily 25 different ways, but I think try 5.
And somehow that strategy should lead to a reason, perhaps why you decided to choose one over the other.
Top or bottom.
And it's good to know that if you think in the future, where are you leading towards, and you can make a decision that way too.
Yeah, so I mean, just to take a look at that one that I got out up here. This is the kind of only thing you're really guaranteed. And I would say even, if we looked at that, that might be up for debate as well. There's other options that could come off of 3 different curves in terms of how they. I think this is the kind of more sensical one, but this is just my case in point on this one. There might be ones where this is kind of fairly evenly distributed, and you're not exactly sure how to go, and that's going to be another type of orientation, because at that time you're going to have that mass done, and you're going to kind of know how it looks in space. So it might be that I actually have something more difficult, So if I actually have those curves and I decide that I want to loft them differently, if I use a loft command and pick the order, this bow tie thing is just happening because I picked starts and ends. But if I hit the align curve option, I can kind of suss that out by clicking on different ones. I'm going to do straight section. Okay. Oops. Back to measure. So let me run again. So in this case, I flipped the surface, and that's all I did, right? And that's another option of that same exact input. Right, there's another one. So I could do this one. You get a difficulty points on that one if you're going to have a feature like that in your landscape. But I think it's super interesting. I mean, and totally legitimate in terms of the operation.
What is the definition of interesting?
Anything I do is typically the definition of interesting in my world. Outside, no. Yeah.
If it's easy,
if it's easy, it tends to be a red flag. So let me pick this one. I think that might have been the one I did. No, that's a different one, so that's fine. That's cool.
Hey, Mike,
yeah.
Just real quick, you're going to get torqued surfaces too, right? I think I just noticed one that's
not the way this is set up, no.
So is it impossible to get torqued? Because this one just looked like it rotated.
Let me go back.
This one. Is that flat?
I think it's just the shading, because it's going to do straight section connections with that tool. Yeah. If you didn't do straight sections, you would get probably something like that. But in terms of buildability, this is going to give you a better option. Back way too far in our process. Bad blast from the past. All right, let me go back to where we were to kind of finish it up. So this is where I've got this polysurface here. It's on this layer, and I'm now talking about, well, where do I go from here? So this is a kind of a different situation now. I'll turn my colored back faces off. Maybe on this one I want to go downwards, so I would say duplicate this edge down here with that surface, and maybe I want to go and bend this back up So I draw triangle. I can just hit close to close that triangle, right? So to kind of create this, run another loft from that curve to that new one that I just made. I'll make my active layer this red layer, so the new stuff will be red, and I said okay, straight sections. That goes down there, and then I do a planar surface. With that triangle that I made. Oh, the triangle's up here though. So. Totally different landscape, right? I'm gonna join it. And go back to, let's see, I might have lost my box that I made, so let me go back to my boundary. So now I've got a totally different kind of situation with the same object. So it's definitely like your considerations are not so much in the object, but the actual horizon itself, right? That's going to kind of dictate how this thing operates and moving forward. So let me look at my boundary. I had a boundary here somewhere. Bounding box.
Is this considered more interesting than the previous one?
I don't know how to answer that one. It all depends. Maybe challenging. I would say be kind of specific about what would make it. If you find, so what makes this challenging? Well, you've got an intersection that happens here and here in plan, right? So in the kind of top view, right, that's not the view that squares out like before. Right? What it does is it eventually, actually I might be missing a little top corner there, up at the top here. I've got to get that guy to top off and intersect the box, right? So I didn't go laterally, I actually have a cut through like that, and it's in terms of like being, I think it's a more of a challenge, right? Because you still have to decide on, we still haven't given this orientation, and kind of get back to what Anthony's saying. Like, I don't know if I'm on a cliff or what right now in terms of the orientation. And then the next step is for you to decide what that orientation is. Taking, in your mind's eye, kind of thinking about where's my light coming from, right? I've got this kind of orbit object. We've used this as a kind of a jumping off point, but you can really see it as something like that, where this is the kind of context of my light at all times. This does not change. This is a kind of a scaleless fact about what's going on in the model. So let me kind of go back and finish this one up just to see what it would yield. There's the guy I was looking for. Solid base. So,
sorry,
yeah.
anticipation for Wednesday's workshop. Shall we require them to actually complete the box? Like in this case.
I would.
Okay.
Yeah, I think it's totally doable. And if you have it, at least then we can kind of pinpoint what the issue is, to not kind of leave it up to just crossing your fingers and you're going to figure out sometime, since we've already got all this geometry. I think that's a good way to do it. I'm just going to finish that one little piece that I'm missing here. So put it on top polys.
Essentially, we're creating this polygon blocks and it's resting on this topography that you're creating. I'm still pretty confused.
You don't sound confused. That's kind of, yeah.
What determines good?
Hmm?
What determines good? Because there's so many different ways you can do this.
Nothing yet.
Just
This is
barely-
process. What, you determine that.
I actually think this is a super, like, this is a really good question, right? Like, what determines good, right? So the only way I can answer that is actually if you allow yourself to see how many different ways can I do the same thing. The process is not linear in that sense. It allows you to actually make a few critical decisions along the way. Another way of saying, like, if I have 15, right? 15 versions of this. Now I might be able to actually group ones that are sort of cliffhangers, others are valley like hangouts, and others are sitting on top of the crown, right? Like, so now which ones, right? Like, what's good or bad, right? I think it's maybe a kind of terminology thing. It's not so much good or bad, but it's maybe advantageous towards something else, right? And one is, I think that's been the topic throughout the quarter here, is the light, the relationship to the orbit, the relationship of the kind of 5 sources of light, right, or spots. So I think there's previous discussions that could help us identify which one positions itself more advantageous, right? So,
Yeah. I think you define what's good because you're the one that's going to have an objective or a subjective kind of argument. I can tell you whether or not you follow the process and it makes sense from the context of what we're doing in terms of being correct or not. But if you like in your case, a cliffhanger, and I don't like a cliffhanger, why is my point of view more valid than yours? I'm here to see if you actually understand how the inputs generate an output or not, if you understand how something is actually ran or not, if you kind of appreciate the generation that happens, not so much. If I knew what I wanted ahead of time, I would say, make this and come back to me in 2 weeks, and then we could talk about how you made what I wanted. I don't know what you're going to make. I want that to be a dialogue, not something that's owed to me.
And I think that's why it's important. It's important to keep a record of your actions because it becomes a story.
Every decision has an argument in it, right? So I've made this thing, right? What would be my argument in terms of splitting it? Because before it's kind of a loaded issue. The bottom one is the one we keep. That's the ground. Now that's less obvious. And in fact, it's never obvious. So what I really need, I need a solid and I need a void. I need a dark and I need a light. We know that our light source is out there. So if I decide this time that I'm going to split it.
I have a quick question before you change it. The red, that so you say you wanted it to be like square, a full square when you see it from like the top view.
In that case it was, because that was the projection that works.
So it's not like it has to be like.
It has to bisect that volume, that square, right? You've got to slice it in 2 parts. Yeah. And it has to be based on that input geometry. So everything here is based on those 3 surfaces. I've basically assembled in 5 facets or 6 facets something that already exists in that model that you just did. All these surfaces exist within the yard model. If you wanted to, you could go out there right now and build these physically and make the same geometry, right? So let's say I split this with a polysurface. So why do I want this one or do I want the other one? So where would I be if I told you one was right or one was wrong? And how would you actually believe me if I told you, right?
You're building a language. You have to start from like what is.
I'm kind of interested in the kind of explicit decision that was made. If I look at my neighbor and I see something like that, I know it could have been the other way, and I'm more interested in the why than the what. Because the what is known to me because if I needed to make that model, I know how I can make it. I want to know what's in. I'm thinking there's something pretty deliberate when someone comes out with something like that. I don't think that's just kind of happenstance because they definitely could have taken maybe a road more like the one I did before, where it was kind of more predictable, right? And again, I mean, this is something, but in your mind's eye, you don't even know what this is until you actually perform it. And I think that's interesting, for lack of to use the parlance of today.
You still have the option of deciding which surface.
What's the orientation exactly, right? So at this point, you know what your original question is what happens now, right? What's my gravitation? One thing I'll point out that is the orbit, right? You know, if my orbit's here, I'll scale it just for visibility, but that's not a necessary part. I would say if you do that, keep your orbit in mind and rotate the orbit as well, because the orbit still is your kind of, you know, orientation. So if I take this and I decide that this is actually something that happens on a different axis, and I just rotate everything by 90 degrees. Just bring the orbit along. But yeah, there's a good question. So like all around so far.
I'm just thinking about how it's going to actually fit in, because with this one it's a little bit more feasible to actually fit it back in, whereas when you did the opposite side, the mass at the top created a situation where it's tight at the top and then wide at the bottom.
Yeah.
You wouldn't be able to fit that shape into the smaller.
Exactly. Yeah. I mean, it would be a building, you know, situation. I don't know how much you want to play the hand in terms of how this thing will be constructed later. It's up to you. But this is definitely not a physical solid either. If there's accessibility that happens.
So you could say the next model or the series of models that you're going to construct there is one is the physical model. Let's say it's going to be the actual wireframe of the actual shard or whatever you want to call it, right? And the landscape. So establishing that relationship. So one is planar and one is sort of linear to begin with. And looking forward, you can imagine we're going to introduce other components to it that will help you evaluate what we have. So in terms of how you inhabit the facility, if you actually get in there. So two models ahead.
Two models?
Yes, yeah. So one is the actual landscape. We're going to call it the landscape. Right? The other is the actual object or linear, the unfolded part. No, one is going to be cardboard and one is going to be your solder. Who's looked out for the soldering job? Might be able to tattoo the turn because tattoo.
Any kind of more? Are there any more technical questions before I stop this? Does it make sense? Okay. Okay. Thanks, guys.